Welcome to this third video on SOHCAHTOA, where we're revising certain trig functions of a right angle triangle. In today's video, we'll be looking at the cosine function. A quick recap of our previous video, video 2. In video 2, we're looking at the sine function. We can see here we've got 1, 2, 3 different functions that we're working our way through. Today we're looking at the cosine function, and our previous video, number 2, we were looking at the sine function. Of course, in video 4, we'll be looking at the tan function as well. During our work on the sine function, we identified the hypotenuse side length and the opposite side length because they're the two that create the ratio that's important to the sine trig function, and of course, the angle theta. We rearranged this equation to find three separate equations that can be used. One, the top one, here is to calculate the opposite side length. The second one is we want to find the unknown hypotenuse side length, and the third one is if we need to calculate the angle of a right angle triangle using the sine function. Then finally, we examined three examples to apply these three different rules. Today, we'll be looking at the cosine function. Now, all these three trigonometry functions require an angle and two side lengths. The cosine actually requires the adjacent and the hypotenuse side length. That's what we'll be focusing on today. So let's examine the cosine function. Here we have the hypotenuse length highlighted red, the adjacent length highlighted purple, and of course the angle theta with the yellow background. Cosine of theta, the angle, is equal to the adjacent length divided by the hypotenuse length. So here's our starting point. Let's see, if we were to multiply both sides by the hypotenuse, as you can with equations, you can multiply both sides by the same factor. We find that on the right-hand side of our equation, of our equal sign, we've got a divide by hypotenuse and a multiply by hypotenuse. Those two can effectively cancel each other out. If I have a value and I times by 2 and then I divide it by 2, I'm getting back to my original value. So they can cancel out and generate a new expression that says the hypotenuse length multiplied by the cosine of the angle theta is equal to the adjacent length. So I've written this up here, except I've made the adjacent length the subject. So the adjacent length is equal to the hypotenuse length multiplied by the cosine of the angle theta. That's our first derived or created equation. Let's look at this one and see what else we can change and derive and make the subject. So at the moment here, I've got my adjacent side length as a subject. How about here if I were to divide both the left and right hand side by cos of theta? Now in doing so, I've got here hypotenuse multiplied by cos theta and then divided by cos theta. Those two functions will divide through, cancel out, much like taking a number, multiplying it by 2, then dividing it by 2. You're left with the number. That can now be rewritten as hypotenuse side length is equal to the adjacent side length divided by the cosine of the angle theta. It's our second derived expression. Now finally, we've looked at calculating an equation for the adjacent side length. We've now got an equation for the hypotenuse side length. Our final equation is going to be how can we calculate, if we had two side lengths, how can we calculate the angle theta? So back to the start. Now, before we were multiplying to get rid of division, here we've got cosine of the angle theta. Now to get theta by itself, we need to get rid of this cosine. So the reverse function of cosine is cosine to the negative 1, the inverse cosine. If I take the inverse cosine of the cosine, these two will cancel out. Leave me with the angle theta is equal to the inverse cosine of the ratio of the adjacent length divided by the hypotenuse length. And there we have it, our three different equations that allow us to work out either the adjacent side length, the hypotenuse side length, or the angle theta. Let's summarize these. If I have the first equation, adjacent side length equals hypotenuse side length multiplied by the cosine of theta, that allows us to calculate an unknown adjacent side length. And this second equation, hypotenuse length is equal to the adjacent length divided by the cosine of theta, allows us to find the unknown hypotenuse side length. And finally, if we want to find the angle theta, it's inverse cosine of adjacent over hypotenuse. And here we have it, a summary using our hypotenuse, our adjacent, our angle, and the three various equations that we can use to find an unknown. Let's try these examples. So first of all, our first equation we've looked at will allow us to work out an adjacent side length, given that we know the hypotenuse and the angle. Our second equation allows us to work out the length of the diagonal, given that we know the adjacent length and the angle. Our third and final example allows us to work out the angle theta, given that we know the adjacent and the hypotenuse side lengths. So let's look at these three examples. First of all, we have here a right angle triangle with an angle of 30 degrees, a diagonal or a hypotenuse of 8 meters, and we want to know what the adjacent side length x is. So the adjacent is the question mark, hypotenuse is 8, and the angle theta is 30. Now, which of these equations allows us to work out the adjacent? Okay, clearly it's the top one. So we'll write that down. Adjacent side length is equal to the hypotenuse side length multiplied by the cosine of theta. Let's now slot in our values. The hypotenuse was 8 and the angle was 30. Let's calculate these now in a TI calculator. We enter 8 cosine of 30, enter, and we get a value of 4 root 3. We press our conversion button and it returns it back to a decimal of 6.928. So to answer this question, the unknown adjacent side length for the above triangle is 6.93 meters. Example number 2, we want to calculate the unknown hypotenuse side length for the triangle we have here. So the adjacent length is 5 meters. The hypotenuse is the question mark, that's what we're trying to solve. And the angle is 45 degrees. We want to calculate the hypotenuse. Which of these three equations will we use? Of course, we'll use this one with hypotenuse by itself on the left-hand side. So we'll write that down. Hypotenuse length equals adjacent length divided by the cosine of the angle theta. We'll substitute in our values. The adjacent was 5 and the angle was 45. Let's now turn to our calculator, our TI calculator, to solve this. We set up a fraction using the numerator denominator button. And the top of that fraction we have the value of 5, and the bottom of that we have cos 45. I like to tab to the right to get out of the denominator and press enter. So the answer we get here is a 5 root 2. That's in surd format, what we call exact format. I'd like the decimal, so I'm going to press my convert button. Okay, so the side length we get here is 7.07 meters. So finally, to answer this question, the unknown hypotenuse side length for the above triangle is 7.07 meters. Our third and final example. Here we have a triangle with an adjacent side length known, a hypotenuse side length known, but an unknown angle. Let's write these down. The adjacent side length is 2.5 meters. The hypotenuse side length is 5 meters. And the angle theta is the unknown. Which one of these equations allows us to work out the angle theta? This one here down the bottom has theta on the left-hand side by itself. Let's write that down. So we've got the angle theta equals the inverse of cos of the adjacent side length divided by the hypotenuse side length. Let's sub our values in. The adjacent side length was 2.5 and the hypotenuse was 5. Let's try our TI calculator to find an answer. We're after the inverse of cos. So here's a cos button. Our inverse cos is a second function. So we click on the second function. Inverse of cos, we need a fraction. So I click on the button and on the top I've got 2.5. And on the bottom, click down, I've got 5. Complete my brackets, press enter. That gives me an angle of 60 degrees. So to answer this question, the unknown angle for the above triangle is 60 degrees. Thanks once again for watching this video. I hope it's helped clarify some of the ideas of cosine, how we use the cosine trig function to calculate unknown side lengths, and also how to calculate an unknown angle. If you enjoyed this video, please like, share, and comment. And don't forget to subscribe. And once again, thanks for watching.